Okay, happy Monday everyone. Thanks for coming. Your teacher is at a district-wide Common Core training today, so you have this virtual teacher watching it on YouTube. This problem that you're looking at right here is standard form, set equal to 0, and we're going to complete the square. We're going to start with ax squared plus bx, and we're going to move the c to the other side. Then we need to make sure that this leading coefficient becomes a 1, so we're going to divide each of these terms right here by a. Everybody gets divided by a. So you're going to have x squared plus ba over x, or b over a times x equals the opposite of c over a. Then we're going to take half of the b over a, so b over 2a, and put it in a circle over here. We're going to put plus blank, and we're going to take this b over 2a and we're going to square it. So we get b squared over 4a squared, and we're going to add that to both sides by putting them into the two blanks. Remember, we're completing the square, so the left-hand side now, right here, becomes a perfect square trinomial. It's going to factor to x plus b over 2a, quantity squared, is equal to, and I'm just going to change the order on the right-hand side, b squared over 4a squared first, minus c over a. On the right-hand side, I'm going to get a common denominator. And that common denominator will be 4a squared. So I multiply the top and bottom of c over a by 4a, and we end up with 4ac over 4a squared. Some of you are starting to see where we're headed right now. So we have x plus b over 2a, quantity squared, is equal to b squared minus 4ac over 4a squared. We're trying to solve for x here on the left-hand side, so we have to get rid of the squared, so we're going to square root both sides. On the right-hand side, when you square root, you get plus or minus. The square root of the top is going to be b squared minus 4ac under the radical. Over, when you square root the bottom, 4a squared, you're going to get 2a. When you solve for x, you're going to have negative b over 2a, plus or minus, the square root of b squared minus 4ac, all over 2a. And if you put those together, you have the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. What's that? Yeah, it's the quadratic formula. So the quadratic formula comes from taking standard form, ax squared plus bx plus c, and somebody just completed the square in general to solve for x. Remember, x is what you're trying to figure out when you're solving an equation like this, ax squared plus bx plus c equals 0. Now, one part of this, right here, the b squared minus 4ac component in the quadratic formula is called the discriminant. And that discriminant is going to tell you what kind of roots you have, what kind of solutions you will have for that quadratic equation. So if you look at the book notes, here's the book notes, they're giving you x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So here's an equation, and we're going to solve this using quadratic formula. Now, remember, the key to quadratic formula, before you even start, what do you have to be in before we can use quadratic formula? Right, you got to be in standard form. So we have to switch this to standard form. Now, could you complete the square here? Of course, but we're better off with quadratic formula in this case because b is an odd number. If you complete the square, you're going to have to do a lot of work with fractions. So a in this case is, right, it's 1. B, -5, and c, -7. So the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you write that down before you use it for a few problems, you're probably going to get it memorized pretty quick. So in this problem, x is going to equal the opposite of -5 plus or minus the square root of -5 squared minus 4 times a times c all over 2 times a. Now what I want you to notice in my work here is that none of it is simplified as I go. The very first thing I do is I write down a straight plug into my formula and I do all my simplifying after. If you don't do that, if you simplify as you go, you're going to limit the amount of partial credit we can give you. So show this plug-in, then go through and do your simplifying. 5 plus or minus 25 plus 28 over 2. Or 5 plus or minus the square root of 53 over 2. Now in this case, the square root of 53 cannot be simplified. So our values, our solutions, are x equals 5 plus the square root of 53 over 2 and 5 minus the square root of 53 over 2. Obviously this one gets to be a little bit more complicated. So you want to be meticulous in this. 16x squared, set it equal to 0, so minus 40x plus 25 is equal to 0. Now this is not a perfect square trinomial. You might be tempted to think this is a PST, but actually it is a PST. So this PST right here, sorry about that, could be factored and you're going to get 4x minus 5 quantity squared. Now, if you're using quadratic formula, watch what happens. The opposite of -40 plus or minus -40 squared minus 4 times 16 times 25 all over 2 times 16. So you're going to get 40 plus or minus the square root. Now watch what happens in the discriminant. You're going to have a 1600 minus 1600 over 2 times 16, which is 32. What happens under the radical when you have a perfect square trinomial is that you're going to get a 0 under the radical here. So you're only going to get one solution, and that solution is going to be 40 over 32, which is going to reduce to 5 over 4. So there's only going to be one solution. And the solution is x equals 5 over 4. Anytime you have a perfect square trinomial, your discriminant ends up being a 0 right here. So here's your discriminant, b squared minus 4ac. This little chart shows you exactly what's going to happen based on the discriminant. It tells you what kind of roots you're going to have. B squared minus 4AC, if it's greater than 0, then you're going to get two real solutions. In other words, your graph is going to cross the x-axis twice. You have two x-intercepts. When b squared minus 4ac is equal to 0, your graph is only going to cross the x-axis in one place. You have one x-intercept. We say the graph is tangent to the x-axis. Where is it tangent? It's at the vertex. Very good. And when b squared minus 4ac is less than 0, you're going to have two imaginary roots. You're going to have a negative number under the radical, and you're going to have a graph that is either above the x-axis or below the x-axis, and it'll be upside down, horseshoe down. The discriminant tells you about the roots, but it's probably not worth the effort to spend time saying, tell me about the roots. What do we really care about? We actually want to know what the roots are, not just what kind of roots we have. So if you have a question like this, which you'll see in your homework, and you want to know, tell me how many solutions are there and what kind of solutions are they, we can just do b squared minus 4ac and say, okay, I have 10 squared minus 4 times 1 times 23. That would be 100 minus 92, which is a positive 8. According to our chart, when we have b squared minus 4ac is greater than 0, you're going to have two real solutions. Again, it's great to know that there's two real solutions, but in the whole scheme of things, who really cares? We want to know what the solutions are. How are you going to find the solutions? You're going to use quadratic formula. And we can go through and we can ask you a bunch of questions like that. What kind of roots are there? And we're going to say 10 squared minus 4 times 1 times 25 is 100 minus 100, which is 0. That means there's one real root. It's also going to be rational, but that's a little more detail than maybe you need to know. Whereas here you have two real roots because b squared minus 4ac is positive. Here it was 0, so you have one real root. And here, if you do b squared, 10 squared minus 4 times a times c, you're going to get 100 minus 108, which is negative, so there's no real roots. If you look at this equation, the leading coefficient is positive. That means the graph has to be a horseshoe up, so the graph has to be above the x-axis. And it's not going to cross the x-axis, so you have no real roots. Again, who cares? We just don't care. So we don't want to spend a lot of time here looking at what kind of roots. We want to use the quadratic formula, completing the square, and factoring to actually find the roots. Couple of formulas. First one is a dropped object. A dropped object is something like when you are standing on a platform and you drop something over the platform and it falls down to the ground below. You didn't throw it, you didn't push it, you didn't do anything like that. You just held your hand out and let it go. That's a dropped object. So the object itself will start up somewhere and then fall to the ground, and then it lands on the ground. What we want to look at with this equation, h of t, that's the height of the object. Negative 16t squared plus h sub 0 will give you the height of the object after t seconds from when you dropped it. If you look at a graph of the height of the object will start at whatever h sub 0 is. The initial height when time is 0 is going to be h sub 0, and then as time progresses on the horizontal axis, as we move from left to right, the object's going to approach the ground, and it's going to look, when you graph this, look like a parabolic function. Again, we're not talking about throwing the rock or the ball or anything. We're just dropping it. This graph isn't the path of the ball right here. This is the height after t seconds. So after 1 second, you can see right here, the object is lower than where it was when it started. After 2 seconds, the object is even lower. And after 3 seconds, which would be way over here, the object has already been on the ground for a while. H sub 0 is your starting height. T is time. There are 2 unknowns. You're always going to ask yourself, do I know the height or do I know the time? Your points, your ordered pairs, are always t, comma, h of t. Time, height, which one do you know? So if you were going to drop a bowling ball off the Empire State Building, which is 1,454 feet above the ground, how long until the ball is halfway to the ground? And then the second follow-up question, how long will it take to hit the ground? So our formula, h of t, is equal to negative 16 t squared plus 1454. If you look at this graphically, so here's the Empire State Building, and you're standing on the top of the building. Here you are. Okay, so my drawing's not that good. And you hold the bowling ball over there and let it go. And David Letterman clears an area for you at the bottom. And we want to know, when does the bowling ball hit the ground? We also want to know, when is the bowling ball halfway to the ground? Let's do halfway first. What do you know? Do you know how long it took to get there, or how high it is when it's halfway? Right, how high it is. Where do you put the height? Right here, for h of t. What is the height? 727 would be how high it is off the ground when it's halfway to the ground. We want to know how long. How long did it take to get there? That's the time. So the t is still the variable. Now we can solve this algebraically pretty easily because there's no b value, there's no bx term, or in this case there's no t to the first power. So if we subtract 1454, we get negative 727 equals negative 16t squared. Negative 727 divided by negative 16 is 45.4375, and that's going to be equal to t squared. In order to find out what t is, you square root both sides. And you get plus or minus 6.741 if we round to 3 decimal places for t. So the ball will be halfway to the ground in 6.741 seconds. That would be the answer to the first question. The question's in words, the answer's in words. If you're looking at a sketch of what happens in terms of height and time, this is the height, this is the time. So we were going to start right here at 1454 feet. And then the height is going to go like this. When we get to 727, we're right here. That took 6.741 seconds. The next question is, when does it get to the ground? What do you know when the ball is on the ground? Do you know the time or the height? We know the height. What's the height of the ball when it's on the ground? How high off the ground is it? 0 feet off the ground. So that's your equation when the ball hits the ground. You want to know how long it took. That's t. So we subtract the 1454, and we divide by negative 16, and you get 90.875 equals t squared. If you square root, you're going to get 9.533 equals t, plus or minus. Now, obviously, it's not the minus. There's no negative time. So it takes 9.533 seconds for the ball to reach the ground. That's a dropped object. If you throw the object, we have to add a middle term, v sub 0 times t. And in our course, v sub 0 stands for the vertical velocity. It has nothing, it's already taken into account the angle at which it's been thrown, and it's talking about how fast the object is moving in an upward direction. Tomorrow, you can ask whoever your teacher is, explain this upward direction. What does that mean if you're not understanding what that is? H of t is still your height, t is still your time, and h sub 0 is still the initial height from which you throw it. V sub 0 is the vertical velocity. The vertical velocity is almost always going to be given to you, as is the initial height, unless those are the things you're looking for. Dropped objects have no middle term. Launched objects have the middle term. Here's the middle term. And when you get to maybe a physics class, you may start using this much more complicated formula where you have to take into account the velocity, the actual velocity of the object. That's what v sub 0 here is. And the angle at which the object is launched. This will happen in a different course, not our course. So here's an object. It may not be the best object to use because it looks like it has its own power source, but what we want you to realize is that the object is launched and it doesn't have a power source. It runs out of gas, it keeps going up, 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 and it's following this path right here, and then it comes back down to the ground. The first question that we almost always ask is for you to write the model for this. Well, that's the function that we just talked about right here. Negative 16t squared plus v sub 0t plus h sub 0. So in this situation here, h of t is going to equal negative 16t squared plus the initial velocity is 64 times t plus an initial height of 80 feet. That's your function. That will tell you the height of this object at any given time. The next question that we usually ask, how long does it take till you reach the maximum height? Well, let's take a look at what this object does in terms of height. It starts at 80 feet and is launched upward, and then it falls to the ground. Where is the maximum height going to be attained? Well, that place, that location is called the vertex. You're finding the vertex. What part of the vertex are you finding if they're asking you to find the time? Well, that's the x-coordinate of your vertex, or in this equation, it's the t-coordinate. How do you find the t-coordinate of the vertex? opposite of b over 2 times a. What is that going to tell you? It's going to tell you how long to get to the maximum. So in this equation, t for your vertex is going to be the opposite of 64 over 2 times negative 16. So that's going to give you a t coordinate of your vertex of 2. How many seconds until the maximum height is reached? Max height in 2 seconds. So it's going to reach the max height in 2 seconds. Questions in word, answers in words. Don't write t equals 2. Answer it in words for us. The third question is a follow-up on the B question. What will the maximum height be? Well, the maximum height will be the y component, or in this case the h of t component of the vertex. H of t equals negative 16 t squared plus 64 t plus 80. What are we going to plug in for t if we want the maximum height? The thing we're going to plug in for t is the answer to that B question, 2 seconds. Negative 16 times 2 squared plus 64 times 2 plus 80. If you want to work that out, you're going to get a negative 64 plus 128 plus 80. It's going to be 144. Max height will be 144 feet. And then the last question that we'll ask you in this series on this problem is when, how long till it hits the ground? If you go back and look at your graph, here we are. We want to know when it hits the ground. What do you know about the object when it hits the ground? Height or time? We know the height. What is the height when the object's on the ground? The height is 0. So we're going to plug in a 0 for h of t. In our function, h of t equals negative 16t squared plus 64t plus 80. So we put in for the height 0. And we're going to solve for t. How are you going to solve for t? Well, we could factor, we can complete the square, and we can do quadratic formula. Now, if you're going to do quadratic formula, you're probably going to use a calculator. There's no need to simplify at all, and most of the times we can't simplify. In this particular problem, you could simplify because every single one of those coefficients is going to be divisible by 16. So you could divide out the 16. But if you're going to probably use quadratic formula, it's not going to matter. T is going to equal the opposite of 64. Plus or minus the square root of 64 squared minus 4 times negative 16 times 80 all over 2 times negative 16. So utilize your calculator for this kind of work. And you're going to get 92/16 under the radical and a negative 32 on the bottom. Now, 92/16, as it happens, is a perfect square, which means that we could have factored this. So if you wanted to try to factor, you could have, but we're going to use quadratic formula. Now, that means that we have negative 64 plus 96 over negative 32, or negative 64 minus 96 over negative 32. And we want to find out which of those answers is the one that will work for us. Negative 64 plus 96 is going to be a positive 32 over negative 32, which is a negative 1. On the other side, negative 64 minus 96 is going to be a negative 160. Divided by negative 32 is going to be 5. Again, this is t equals. Time can't be negative, so we're going to take t equals 5. It takes 5 seconds to hit the ground. Not t equals 5. It's a word problem. Answer it in words. So here's a separate question, very similar. Juggler tosses a ball in the air. The ball leaves the juggler's hand 4 feet above the ground, has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? So this is a thinking question. Oh, thinking's hard. You don't usually make us think. We just repeat and do. What should you do first? Great idea. Let's graph it. We're starting at 4 feet. Where's the ball going? Right up. Then where's it going? Right down until it gets caught. Where did it get caught? Right here at 3 feet. Okay? So we want to know how long was the ball in the air. Well, when it starts, that's time 0. We want to know what this is, this t value right here. What do you know about the ball when it's caught? Do you know the time or the height? If you knew the time, we wouldn't be asking you to find it, would we? You know the height. What is the height? The height when they catch it? Right here, 3 feet. Where do you plug the height? In for the h of t. So we're going to plug right here, 3, in for the height. The initial velocity was 40 feet per second times t, and the initial height was 4. If we subtract 3, we have this equation right here. We want to find out what t is, so we're going to use the quadratic formula. T is going to equal the opposite of 40, plus or minus the square root of 40 squared minus 4 times negative 16 times 1 all over 2 times negative 16. You're simplifying negative 40 plus or minus the square root of 1600 plus 64 over negative 32. That's going to give you negative 40 plus or minus 40.792 over, sorry, Mr. Pagel just walked in, so now my train of thought here. So negative 32 right here. So that means we're going to have negative 40 plus 40.792 over negative 32, or negative 40 minus 40.792 over negative 32. This is going to give you a negative answer. We don't need negative answers because that's not possible. The or is where we're going to get our answer. So you're going to have negative 80.792 divided by negative 32. that's going to give you 2.525. So if you look at your graph right here, the path of the ball from when it leaves his hand to when he catches it is going to take 2.525 seconds. To catch the ball. 2.525 seconds to catch the ball. This is your assignment. It takes a lot of practice to get the quadratic formula down. Once you have it down, it's just a matter of being meticulous and careful. If you have questions, we're going to answer them for you tomorrow. This is longer than we'd like it to be, but this is a pretty important lesson. Get the quadratic formula memorized. Work on the note-taking guide that you're about to be handed, and have a great rest of your class.